All right, what is up, guys? Mr. Rushka here. Gonna go over the 4.1 notes with you guys, okay? Solving systems of linear equations that have two variables in them, an x and a y, okay? So let's just jump right into it, okay? So the first thing we're gonna do is determine whether this ordered pair here, 3, 1, is a solution of my system here. How do I check that, okay? So let's look at my ordered pair here, right? What's the general form for an ordered pair of two variables? It's going to be an x, y. So right here, my x is 3, my first number in my ordered pair, and my y is my 1, my second number in that ordered pair. So I have x equals 3, x equals 1, all right? And we're wondering whether this, what the heck? We're wondering whether this ordered pair solves this system of inequalities. What that means is when I plug, so when I take, let's say I'm going to highlight here, when I take my x here and plug it in for x right here, and when I take my y here and plug it in for y here, and simplify on the left, that should equal my number on the right. Okay, so let's do that, right? So let's plug in my x, so that's 3. Let's plug in my y, which is 1. So 3 plus 1, right? And that equals 4. Does that equal 4? Yes. 3 plus 1 equals 4, okay? Right? 4 equals 4. Good. All right, so my ordered pair solves the first equation, right? But in order to say that my ordered pair solves solves the entire system, I have to make sure it solves both equations. So let's check this bottom one now, okay? So let's plug my x in for x and my y in for y, okay? So plugging everything in, right? This is from chapter 1, okay? We have 3 minus, what's my y? 1 equals 2. Does 3 minus 1 equal 2? Yes, it does. 2 equals 2, yahoo, okay? So yes, it's a solution. So my ordered pair here, 3, 1 is a solution of this system, okay? That's how we determine that. Part B, negative 2x plus y equals 4 and negative 3x, all right? This is technically plus 0y equals 2y plus 8. That's technically a 0y there, okay? So we want to see whether it's a solution of the system, okay? All right, so we got my x here and my y. So my x equals 1/2. My y equals positive 3. Okay. Okay, so we're going to get 2 times my x, which is 1/2, plus my y, which is 3, equals 4. Okay, let's see, is that true? Okay, let's see if that holds true. So 2 times 1/2 is 1. Then we have plus 3 still, that equals 4. Does 1 plus 3 equal 4? Yes, it does. So my ordered pair solves my first equation there, okay? So my ordered pair solves my first equation. Let's look at the second one, okay? So let's plug in my x here, my y here, and here. Okay, so we have negative 3 times 1/2 plus 0 times 3 equals 2 times 3 plus 8, okay? So we're going to go ahead and simplify both sides of this equation, and then we're going to check to see if they're equal, and if they're equal, then it's a solution. If they're not, then it's not a solution, okay? So let's simplify the left side. Negative 3 times 1/2 is negative 3/2. 0 times 3 is 0. That equals 2 times 3, which is 6. 6 plus 8 is 14, okay? So we have negative 3/2 equals 14. Is that true? No! Negative 3/2 does not equal 14, okay? So my ordered pair is not a solution of the second equation, okay? Now remember, in order for us to say that this ordered pair is a solution of this system, the ordered pair has to be a solution to both these equations. It has to work when we plug it into both these equations, okay? Since it only works when we plug it into the top equation, and it does not work when we plug it into the bottom equation, we have to say that the ordered pair is not a solution. Not a solution of of our system. All right. There you go. Hate to burst your bubble. All right. All right, yeah, so pause, rewind, ask Mr. Miller for help if you need it, okay? So, yeah. Moving on to part A, solve each system by graphing, okay? So now instead of them giving us an ordered pair and just like plugging and chugging to check if it's a solution, they actually want us to start with just the system of equations, no like ordered pair over here, and they want us to actually find an x and a y that fit both these equations, okay? So one way we can do that is by graphing. We can do it by graphing, okay? All right, here's how we do this, all right? So what I'm going to do is I'm going to take this first equation here. I'm going to take my first equation, okay? I'm going to solve it for y, put it in slope-intercept form, okay? So I'm going to subtract x. I get y equals 4 minus x, okay? All right. And then the second one right here, down here, I'm going to get y by itself there, so I'm going to subtract x and subtract x, and then cancels out, and then I'm going to divide by -1 on both sides. So that gives me y equals -2 plus x, okay? So y equals 4 minus x, and y equals -2 plus x, okay? So we're going to solve this by graphing. So let's go ahead. I'll color code these for you guys. So let's make this one orange. All right. And then let's make the second one green. All right. So let's graph my orange part, my orange equation first, okay? Let's do that in orange. Y-intercept is +4, so we're going to plot 0, 4 right here. Slope is -1, so I'm going to go down 1 over 1, to the right 1, I should say. Then plot that. Let me just draw a line through those 2 points, okay? So I plotted that first point, that first line, I should say. All right, let's do the green part, okay? So y equals -2 plus x. My y-intercept is 0, -2. And then my slope, the number next to x, is +1. So that's up 1 to the right 1. Plot that. All right, and then we're going to draw our line. There we go, okay. All right, so we've graphed both lines, right? So maybe let's write this down for you guys as steps. 1, graph both lines however you want to, okay? We didn't need to put both these in slope-intercept form. We could have just plotted the intercepts. That would have worked too. So graph both lines however you want. That's our first step that we just did. And then the second step is write down their intersection point. All right, what do I mean by that? The intersection point of 2 lines is the point where they intersect. So right here, right, we're going to write down the ordered pair for this point. That's, okay, 1, 2, 3 to the right and 1 up. So that's 3, 1. My x is 3, my y is 1. Okay. All right, so this ordered pair right here solves my equation. So we're going to have my solution is x equals 3, right? This is my x, and y equals 1, because my second number is my y, okay? So that's my solution here. Final answer, final answer. There we go. All right, we can plug those into here actually to check, right? We're going to have 3 plus 1 equals 4, yup, check. And 3 minus 1 equals 2, yup, check. Okay. There we go. So pause, rewind, do whatever you need to do, okay? Let's move on to part B. All right, so y equals -x plus 3, and 2x plus 2y equals -1, okay? I don't like working with fractions, so this first one right here, this first line right here, let's do blue. Let's let's do this one in blue. Okay, so I'm going to graph this line. It's already in slope-intercept form. There's no fractions, so I'm just going to do it. All right, so I'm just going to graph it as is. Okay, so the y-intercept is 0, 3. Okay, slope is -1, so that's down 1 to the right 1. All right. Boom. Okay. So that's the blue line. Okay, let's do this one in pink. All right. Okay, so if I put this pink line in slope-intercept form, it's going to give me fractions. I don't like fractions, so I'm going to graph it by plotting the x and y-intercepts. Okay, so the x-int, right, that means I plug in 0 for y, so it's going to be 2x plus 2 times 0 equals -1, or 2x equals -1, or x equals -1/2. So my my x-intercept is -1/2, 0. Okay, and then my y-intercept, my y-int. Okay, that means I plug in 0 for x, so 2 times 0 plus 2y equals -1, or just 2y equals -1. Okay, divide by 2, I get y equals -1/2. Okay, so that point, my y-intercept is going to be 0, -1/2. Okay, so let's plot both these intercepts. Okay, so my x-intercept, -1/2, 0, so to the left 1/2, up and down nothing. And then 0, -1/2, so left, right, nothing, and then up 1/2. Okay, cool stuff. And then I'm just going to go ahead and draw a line. Okay, so I think my slope actually is, my slope here is 1, I'm pretty sure, right? Yeah, it's going to be, it's going to be negative. Wait, so -1/2 minus 0. I'm just finding the slope real quick, guys, so I make sure I get it, I plot it correctly. Did I plot that wrong? Oh, I did plot it wrong. Sorry, guys, I plotted it wrong. Okay, so, sorry. So my x-intercept's in the right spot. My y-intercept should be down here. My y should be down here. My slope is -1. Okay. Boom. 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 Sorry about that, guys. Just plotted the y-intercept in the wrong spot. Little mistake. Okay, so looking at these, okay, these two lines look parallel. They look parallel, okay? I don't really trust the way they look, though. Let's think about this, okay? So I just calculated the slope of the pink line up here. Got -1, right? The slope of the blue line is also -1, right? Uh-oh. What's going on? They have different y-intercepts. All right, what's going on here? Oh, no. All right, what do we say about two parallel lines? They have the same slope, different y-ints, right? That happens here, right? They have the same slope, different y-intercepts. So these two lines are parallel. Parallel. Okay, so these two lines are parallel, which means they never intersect. There is no intersection point. They go on forever without ever touching each other, without ever intersecting, okay? All right, so they're parallel, which means there's no intersection point, which means the solution is no solutions. No solutions or empty set. You can write that too. No solutions is your final answer, okay? That's part B. All right, so they're parallel, no solutions, okay? So pause, rewind, ask Mr. Miller for help, okay? Let's go down here, okay? Now down here, we're going to use a method called substitution to solve each system of equations. So instead of graphing and finding the intersection point, we're going to use substitution, okay? This is good for when you have a variable in one of your two equations with a coefficient of 1. So right here, the x in my top equation has a coefficient of 1. That's when it's good to use this, strategy, okay? All right, okay? So the first thing we do is we go to that equation. We look at the top equation because that's our equation where our x has a coefficient of 1. Okay, and we're going to solve that equation for x. Okay, so solve equation with coefficient of 1 for the variable that has a coefficient of 1. Okay, let's do that here. So we got to solve for x. I'm going to get rid of my 6y by adding it to both sides. Okay, I get x equals -9 plus 6y, okay? Now this is called substitution because I'm going to take what's in the green. Oh my gosh, what the heck? So because I'm going to take, what? So I'm going to take what's in the green highlighter here, and I'm going to plug it in for x. I'm going to plug it in for x over here, okay? That's why this is called substitution, okay? So I'm going to put an 8 here, and then in parentheses, I'm going to take this expression and just move it in here, okay? So -9 plus 6y. I just substituted -9 plus 6y for x. And I can't forget to write the rest of this equation right here, okay? So -6y equals -30. All right, Algebra 1, okay? So we remember right now we have one equation and one unknown, so let's solve. So distribute -72 plus 48y minus 6y equals -30. Combine my like terms here. -72 plus 42y equals -30. Okay, add 72 to both sides. 30 plus 72, I'm pretty sure is positive 42. So we have 42y equals 42. Divide both sides by 42. We get y equals 1, okay? All right, all done. Just kidding, we're not done, okay? So we got y, right? But to solve our system of equations, we have to find x as well, right? So we have y equals 1 right here. What we do is we go back up to our green highlighted part so that x equals -9 plus 6y. And now what we're going to do is take our y equals 1 and substitute it for this y up here. We're just going to plug it back into that. We get x equals -9 plus 6 times, that's positive 1 times 6, plus 6 times positive 1. That's equal to -9 plus 6, which equals -3. So x equals -3 is our other variable that we need, okay? So this is my final answer right here. Y equals 1, x equals -3 is going to solve my system of equations, okay? Let's do that over here, okay? Let's do that over here. All right, so I got 1/4 x plus 1/4 y equals 2, and x minus y equals 2. I'm gonna go ahead. So first, let's get rid of these fractions, okay? So if I multiply both sides of this equation by 4, that'll get rid of these fractions for me. So if I do times 4 on the left and I do times 4 on the right, I can do that because I'm doing it to both sides, so I can do that. I'm allowed to do that algebraically, okay? So 4 times 1/4 x is just x. 4 times 1/4 y is just plus y. And then that equals 2 times 4, which is 8, okay? So that's the first thing I'm going to do here. So I got these two equations, okay? So I'm going to take this bottom equation here, and I'm going to solve for x. Get x by itself, okay? So x equals 2 plus y, okay? All right, and then my second step, I forgot to write it down for the other problem. My second step, right, is plug that, plug the expression for that variable into the other equation. All right, so I'm going to take this x equals 2 plus y. Now I'm going to plug it into y over here, okay? So that becomes x plus, in parentheses, 2 plus y equals 8, or x plus 2 plus y equals, oh, I'm sorry. I made a mistake. Sorry about that. Sorry about that. So I'm going to take that x equals 2 plus y and plug it in for x. Duh. Okay, so x equals 2 plus y, so I got to plug that in for x up here. Okay, so I'm going to have 2 plus y plus, in parentheses, plus y equals 8. Okay, or 2 plus y equals 8, or 2 plus 2y equals 8. Subtract 2 from both sides. 2y equals 6, divide by 2, we get y equals 3. We get y equals 3, okay? So then we're going to take this number for y and then sub that up into y over here, okay? So we're going to get x equals 2 plus 3, or x equals 5, okay? There we go. Final answer right here. X equals 5 and y equals 3. That's my final answer, okay? All right, so pause the video, slow down if you need to. All right, so my third step was to solve, because we're going to have solve the equation with one unknown that now has one variable. And then our fourth step, right, our fourth step here was plug that answer back into the expression from step 2. There we go. All right, now let's move on to part C. Part C. Okay, so actually this is nice, right? Because what's step 1? Solve equation with coefficient of 1 for variable that has a coefficient of 1. All right, top equation, it has a variable with a coefficient of 1 right here, right? There's a coefficient of 1 right here. And it's already solved for that variable, right? It's already solved for y. So we can just take it, plug it directly in to the bottom equation, right? Oh, whoops, to the bottom equation, right? So we're going to have 12x plus 4 times, in parentheses, negative 3x plus 8 equals 32. All right, so we're going to have 12. All right, so now let's distribute. 12x minus 12x plus 32 equals 32. Okay. Let's subtract 32 from both sides. All right. All right, so we're going to have 12x minus 12x equals 0. Add 12x to both sides. All right, divide by 12 on both sides. We get x equals x, okay? All right, x equals x. This is strange, right? X equals x, okay? So the solution for x would be any number that equals itself. Well, guess what? Every single number that there is equals itself. So x, the solution for x is all reals. X can be anything. Okay? Since x can be anything, right? Since x can be anything, so y can be anything. And that's because, right, so since x is any number we want, it's any number we want. Since x can be any number we want, when we go to plug back, we can pick any x we want down here. Let's say like 27. We can just go back into here and get y. Then y would be negative 3 times 27 plus 8, right? We don't have to pick 27, though. We can pick any number we want, okay, and just plug it into this equation right here, and that'll give us yet another solution for y, okay? All right. So, yeah, this is going to be an infinitely many solutions, right? There's infinitely many y's we can get and infinitely many x's. Infinitely many solutions. Let me talk to Mrs. Hollis. Actually, Mr. Miller would know this. You could ask him. So we can either write infinitely many solutions, or another way of writing this is all I have to do is just put x here, because if we can pick x, we want all the ordered pairs such that x equals whatever we want, and y equals negative 3x plus 8. So what I did here was I just put an x in the x spot in my ordered pair, and then I took this expression for y up here, and I moved it down here, okay? And like in college algebra, we wrote it like that. I'm not sure if that's what Mrs. Hollis wants. Mr. Miller might know, but I'll ask Mrs. Hollis, okay? So these are both our solutions right here, okay? These are both our solutions, okay? Infinitely many solutions, or these are both our answers, all the ordered pairs such that x is just whatever we want, and then y equals negative 3x plus 8, okay? All right, that's all for part C. Let's go into 4, okay? Number 4, use the elimination method to solve each system of equations. The elimination method. Okay, so the way we do this, right, let's go to part A, right? Here's how this works. Elimination method. What we do is we want to eliminate part of this equation down here, okay? So what we're looking for, so this x has a coefficient of 1. What we're looking for here is look at each variable, your x and y, okay? Okay, compare the coefficient, the top coefficient of x and the bottom coefficient of x, and then the top coefficient of y with the bottom coefficient for y. What we want to do is want to eliminate one of these variables, okay? And when we're going to do that, okay, right, if I add what to negative 6, I get 0, right? That's going to be positive 6. Positive 6 plus negative 6 equals 0. Okay, so what I'm looking for here is I'm looking for a number I can multiply this 1 by that I can add to negative 6 to come up with 0, okay? Right, so we know that positive 6 plus negative 6 equals 0. So if I can multiply this 1 by a number that makes this equal to positive 6, that's what I want to do, okay? So here's how so I'm going to add, that's how I know I want to multiply both sides of the top equation by 6, right? I can't just multiply the left side by 6. If I multiplied just the left side by 6, that would break the rules of algebra, right? Right? Whatever I do to one side of the equation, I have to do to the other. So I'm going to multiply both sides by 6. And I'm just doing that so I can turn this coefficient next to my x and do a positive 6 so I can cancel it in the bottom. Here's what's going to happen. So this becomes 6 times 1x, which is 6x, okay? This becomes 6 times negative 4y, which is negative 24y. And then this right here becomes negative 48. So that equals negative 48. Okay. Now what I'm going to do, right, now I have my positive 6x and my negative 6x. What I'm going to do is I'm going to add these two equations together. I'm just going to add them together, okay? All right, how do I add two equations? Well, all you do is I'm just going to go term by term, okay? So negative 6x plus 6x is 0, so that's going to cancel, right? Negative 3y plus negative 24y is negative 27y. All right, I keep my equal sign where it is, okay? Keep my equal sign where it is. And negative 6 plus negative 48 is negative 54. All right, look. It's called elimination because what I've done is I've eliminated the variable for x. I've eliminated my x variable in such a way that now I have one equation with one unknown, And I can solve this just like I did in Algebra 1, okay? So I'm just going to divide both sides by negative 27, divide by negative 27. Negative 54 divided by negative 27 is positive 2. So that's my solution for y, okay? That's going to be my solution for y. Super convenient, okay? Then how do I get x, right? I need both an x and a y to solve this. Well, glad you asked. Okay, I can just go back to this original top equation up here. So let me do that. Okay, x minus 4y equals negative 8. And what I can do is I can plug in my y into this equation. All right, so I'm going to do that. I know y is equal to 2 now, so I can just plug it in up here. I get x minus 4 times 2 equals 8. Equals negative 8, right? And now right here I've got an equation. It's one unknown, one equation. I can solve this just like I did in Algebra 1, okay? So I get x minus 8 equals negative 8. Add 8 to both sides. Get x equals 0, okay? So y equals 2, x equals 0. That's going to be my final answers here, okay? So there we go. Boom. Got it. Got it down, okay? Let's try that over here, okay? So I'm looking at b, okay? I'm looking at numbers I could multiply both sides of either of these equations by, such that I could add one equation to the other to cancel out a variable, okay? So this one's not as simple, right? What I'm going to have to do, right, on this last problem, the difference was I only had to multiply the top equation by a number, right? Over here, right, I need to multiply, unless I want to go into fraction land, which I don't, I need to multiply both equations by a number such that when I add the two equations together, two of the variables are going to cancel, okay? So let's think about this, okay? So do you guys remember the least common multiple from middle school, right? Least common multiple, LCM, okay? So when I'm looking at these four numbers, I'm looking at the vertical pairs of coefficients here that I'm circling. I'm looking at those, and I'm thinking, okay, what can I multiply 3x by and then 2x by, such that when I add this column up, it just cancels, okay? Well, I'm thinking, okay, well, 6 and negative 6, okay? 6 plus negative 6, that's their least common multiple, is 6. So 6 plus negative 6 is going to be 0. I can cancel out my x and be left with one equation with just y to solve for, okay? So I want to have this to be a positive 6, so to get 3 to be a positive 6, I multiply by 2. So I'm going to multiply both sides of this equation by 2. All right, that's going to give me, distribute 6x plus 12y equals 6. All right, and then down here, right, I want this, right? I'm going to add 6x to the bottom equation. So my bottom coefficient for x here has to be negative 6. So what do I multiply 2 by to get negative 6? Well, I multiply it by negative 3. Okay, so multiply the left side by negative 3, multiply the right side by negative 3. Okay, right, that's going to give me negative 6x minus 27y. That's going to equal, okay, negative 8 times negative 3 is going to be 24, okay? So I multiplied both sides of both equations by my number, right? And I did that, right? You might have been wondering, well, Mr. Rushko, why are you doing that? I did that, right? So now when I add these two equations together, my x's are going to cancel. So let me add these together real quick, okay? Going to add them. Okay, so I'm just going to go term by term. 6x plus negative 6x is going to cancel. Then 12y plus negative 27y is going to be negative 15y, correct? And then 6 plus 24 is going to be 30. Okay? All right, divide both sides by negative 15. All right, y equals negative 2. Okay, so there's my solution for y, okay? And then again, I don't have to, and then once I know what y is, I can just go back to one of my original equations, easy peasy, okay? And then I can just plug in y equals -2 for y in this first equation. Oh, sorry. So I can just plug in y right here. That'll give me 3x plus 6 times -2 equals 3. Okay, so I went back to the original equation, so without the multiplying everything. Okay, so I did 3x plus 6 times -2 right here equals 3. Okay, so now I have one equation with one unknown that I can solve. Let me just write that as -12. Sorry, it's confusing. So 3x minus 12 equals 3. Add 12 to both sides. 3x equals 15. Divide by 3. Divide by 3. X equals 5. Boom. Now I'm done. So I got x equals 5 and y equals -2. Final solution right there. Done. Okay, so that solves my system of equations. And again, we can always go back and check these, right? I can just plug in my x to both equations here, my y to both equations. Right, so that checks out. Plug both my x and my y into the bottom equation. Boom, that checks out, okay? So that's how I can check my work here on a quiz or test, okay? C, let's go down to part C. Oh, man. Ugh. All right, well, it looks kind of gross at first, right? We've got all these fractions here until you realize, looking at the y's, right? My positive 1/4 y and my negative 1/4 y, these are already opposites, right? That means that when I add these two equations, they'll just cancel, right? I don't have to do any multiplying or any of that stuff at the beginning, okay? So let's do that, okay? So let's just go ahead and add them together right at the beginning, okay? Get out your TI-84 to add those fractions together. All right, so 2/3 x plus 1/2 x, right? As a math answer fraction, that's going to be 7/6 x, okay? My positive 1/4 and my negative 1/4 are going to cancel. That's going to equal -3/2 plus -2, which is -7/2, okay? Right, and then now I have one equation with one unknown. Easy money, okay? So to get rid of this 7/6 right here, I multiply by 6/7 on both sides. Okay, boom, boom. Okay, that becomes x equals, and then -7/2 times 6/7. That's going to be equal to -6/2, which equals -3. So x equals -3. All right, so that's my solution for x, right? And then I still have to get y, though, right? I still have to get y, right? And I can just plug this in to this original equation up here. So let me do that. Okay. Get 2/3, oh, sorry, guys. Get 2/3 times -3 plus 1/4 y equals -3/2. And what I've got up here, guys, is I've got an equation with one unknown, one equation, one unknown, which I can solve for y, okay? It's just got to work with fractions. 2/3 times -3 is, I think it's -2, right? All right, then plus 1/4 y equals -3/2. Add 2 to both sides. 1/4 y equals, and then -3/2 plus 2. So -3/2 plus 2 is 1/2. Okay. Then I just got to multiply both sides by 4/1 to get rid of that 1/4 next to y. Okay, these cancel. I get y equals 4 over 2, which equals 2. So I got y equals 2. Okay, that's my second part of my solution, okay? That's my final answer is x equals -3, y equals 2, okay? So pause, slow down, rewind if you need to, all right. Okay, we'll get to practice this with Mr. Miller, which is nice. All right, let's go on to part D. Part D. All right, this one, it explicitly says to use elimination, so we're going to do that, okay? All right, so the only difference here in this equation is this top equation's in standard form, right? It has that -2 solved out by itself, by constant terms by itself. The bottom is it's kind of almost in slope-intercept form, okay? These work the easiest when both I think it's the easiest to use the elimination method when both equations are in standard form, okay? So my top equation here is in standard form. My bottom, not quite there, right? So to do that, I just got to get -6 by itself, so I'm going to subtract 18x from both sides, right? So minus 18x. That gives me -18x minus 12y equals -6. And then I'm just going to go ahead and copy this top equation down here, okay? So -6x minus 4y equals -2, okay? So now we're using the elimination method, okay? So we want to look at our coefficients here, okay? Let's think, okay? 18 is bigger than 6, okay? So let's think maybe, okay? What's one thing I can multiply -6 by to make it a number that when I add it to -18, it just cancels out, right? Well, what cancels out with -18 when I add? It's going to be +18. So what number do I multiply -6 by to get +18? Well, that's -3, okay? That's one way I could do this. I'm going to look at y too, or I'm also going to look at y, okay? So I can have the y's cancel out. What's one number when I multiply, right? What's a number I can add to -12 that gives me 0, that makes this cancel? Well, if I take +12 and add it to -12, that cancels, okay? So what do I multiply my -4 by to get +12? Okay, so -4 times -3 is what equals +12. So that's what I need to multiply this coefficient by to get +12, okay? And then whatever I do to one side of the equation, I got to do to the other. So I'm going to multiply both sides of this equation by -3, okay? That's going to give me 18x plus 12y equals 6. All right, and this top one's going to give me -18x minus 12y equals -6. Let's see what happens here. All right, so now when I do my adding, I go term by term. That cancels, so this is just 0 down here. That cancels, so I just get 0 equals 0, okay? All right, this is not a contradiction, okay? This is not a contradiction. This is always true, okay? 0 is always equal to 0, okay? When I get something like that, I have infinitely many solutions. That's going to be my answer, okay? Infinitely many solutions. All right. When I come to something that's always true, a constant equals itself, I get infinitely many solutions, just like we did when we were solving equations with one variable, right? Good job, guys. Go ahead. And work on the assignment in class, okay? Ask Mr. Miller for help. Pause, rewind this video, okay? I'll see you guys when I come back, okay? Email me with questions.